comprehensive explanation of Kafka producer components. This mind map outlines the Kafka producer components, providing a deep understanding of how Kafka producers work, their components, and the message flow. Here is a comprehensive breakdown. 1. Overview. The Kafka producer is responsible for publishing messages to Kafka topics. Partitioning decides which partition a message will go to. Serialization converts data into a format that Kafka can store. Reliability ensures message delivery through retries and acknowledgement mechanisms. Key components. A. Producer record. A producer record is the message sent to Kafka. It contains topic, the target Kafka topic to which the message will be published. Key, used to determine the partition. Messages with the same key go to the same partition. Value, the actual payload, data, of the message. Partition, optional explicit partition to send the message. Timestamp, the time the record is produced. B. Partitioner. The partitioner determines the partition for each message. Default behavior. If a key is provided, hash key sent number of partitions. If no key is provided, round-robin distribution. Custom partitioner allows implementing custom logic for partitioning based on message metadata. C. Serializer. A serializer converts the key and value of a producer record into a byte array, which Kafka can handle. Common serializers. String serializer converts string data into bytes. Integer serializer converts integers into bytes. JSON Avro serializer converts complex objects into JSON or Avro formats. D. Buffer pool. The producer uses a buffer pool to temporarily hold messages before they are sent to Kafka. Configurations. Total memory available for buffering records before sending. Batch.size, the maximum size of each batch to send. Purpose. Batching records improves performance and reduces network overhead. Record accumulator. The record accumulator collects records into batches grouped by topic and partition. Sends batches when the batch size, batch.size, is reached, or the linger timeout expires, adding a small delay to increase batching efficiency. F. Sender thread. The sender thread is responsible for dequeuing records from the buffer pool, sending records to Kafka brokers over the network, handling retries and delivery confirmations. G. Acknowledgement mechanism. ACKs. The ACKs setting determines how many acknowledgements are required before the producer considers a message successfully sent. ACKs, no acknowledgement, fastest but unreliable. ACKs equals 1. Only the leader broker acknowledges the record, default setting. ACKs equal all. All in-sync replicas acknowledge the record, ensuring durability. H. Retry mechanism. Kafka producers handle temporary failures using a retry mechanism. Retries, number of retry attempts when a failure occurs. Retry.backoff.ms, the delay between retry attempts. Retries help ensure that transient issues, like network failures, do not cause message loss. Idempotent producer. The idempotent producer ensures that messages are delivered exactly once. Enabled using enable.idempotence true. Prevents duplicates caused by retries. Works with ACKs equals all for the strongest delivery guarantees. 3. Flow of a Kafka producer. 1. Create producer record, define the topic, key, and value for the message. 2. Determine partition. The producer decides the partition using a partitioner. 3. Serialize data. The key and value are serialized into byte arrays. 4. Buffer record. The record accumulator buffers the message into batches. Send to Kafka broker. The sender thread sends batches to Kafka brokers. 6. Acknowledge delivery. Kafka brokers send acknowledgements based on the ACKs setting. 7. Handle retries. If the message fails, the producer retries sending it. 4. Summary. Kafka producers ensure efficient, reliable, and scalable message delivery by handling partitioning with default or custom logic, serialization of messages, buffering and batching for performance optimization, acknowledgements and retries for delivery guarantees. Kafka producers are highly configurable, making them adaptable to various use cases in data streaming and real-time systems.